David Uno, and I'm a master's degree student of Cardiff Metropolitan University, where I am studying data science. Here, I want to walk you through a little project I just did for this course, machine learning course actually. So the project is basically talking about prediction, like the project is basically using machine learning algorithms to different machine learning algorithms to predict if a person has heart disease or not. And I will just walk you quickly through the exploratory analysis of this project. And now, basically, the machine learning techniques I used. I used the random forest classifiers, I used the KNeighbours, I used the decision tree, and I used the neural networks. So let's just dig in to the exploratory analysis of this assignment. So basically, this is I imported my libraries, imported my data, like everyone would do. So then I had to like visualize my data to see if I had any missing values. I have none. If not, there would have been some like yellow marks this on this um on this visualization here. So furthermore, let's just dig in quickly. So from here we can see that there are more people with heart disease than there are people without heart disease. So we had to dig in further and we looked at the age distribution. And we can see that the lowest age here is 29 and the maximum is 77 by looking at this. And we had to know this. I didn't know this just by looking at this. I had to like do a quick thing to see the age, the minimum age, and to see the maximum age of all the patients in the data set, and the mean. So the mean of the ages is 54.5. So furthermore, we had to dig in and say, okay, looking at the sex distribution, it's evident that there are more men with heart disease than there are women with heart disease. So we dug in further and we looked at, and it is also evident that most men, most people with heart disease are actually asymptomatic. No form of chest pain, or there are more people that are asymptomatic than there are people with a type of chest pain. The non-anginal pain comes next, and the atypical angina comes after that. So furthermore, we look forward to the slope. We see that it is downsloping, and it is downsloping. Then we look at the fasting blood sugar. Yes, now this is an interesting one because now fasting blood sugar over the time, some people say it leads to heart disease and not. But it is very rare. From looking at this data, it is very rare because fasting blood sugar in this data set has shown that it isn't even like a factor. It isn't a major factor that is that plays out that people have heart disease. It isn't a major factor. So yeah, we come into the numeric values. We can see that they are all linear. They're all linear. Like look at this, the age. Look at the rest, ECG. Looking at the cholesterol, and looking at the maximum heart rate achieved. We can see that they are all linear. Now we look at the correlation here. Looking at the correlation now, we're looking for positive correlation from all the other features, from the features like the other columns. We're looking for which one matches the target, which is positively correlated to the target. So obviously the maximum heart rate achieved has nothing to do with heart disease, so it's even negative. It's negatively correlated. However, the remaining on this dataset are positively correlated. However, some of them are really low, like the cholesterol and the fasting blood sugar. Then, chest pain is really significant when predicting for heart disease. Old peak, the ST depression is also looking very important when looking for this. The number of major vessels is very important. 52. 52 is like positively correlating with the target, and the tau too is also correlating with the target. So here we kind of like do a his plot to show, and from here we can see that the age is no is normally distributed. The rest the rest ECG is is skewed to the left, the maximum heart rate achieved is